All right, continuing on with section 6.03 on vectors. The next thing we need to learn how to do is find a unit vector. Okay, so for example, suppose we needed to find a unit vector, we'll call it u, with the same direction as this given vector v, -4, 6. Okay, so here I've drawn that vector, -4, 6. Notice I've doubled my scale to make it easier to see. I'll try to focus that a little bit better. So what is a unit vector? Okay, well, it's in the name, unit. Unit means one, like in Spanish, uno, right? That prefix means one. So we want to find a vector that has a magnitude of 1. That's what that means. Okay, this vector obviously doesn't have a magnitude of 1. Okay, well, let's find the magnitude of the vector that we have, because we're going to need to do that anyway. Okay, remember that the magnitude of that vector, you're really just using the Pythagorean theorem. The x component is -4, the y component is 6. Okay, so we can find the magnitude of v. I'll put that over here. Magnitude of v equals the square root of 4 squared plus 6 squared, right? So that's going to be 4 squared is 16 plus 6 squared is 36. So that's going to be square root of 52. Okay, so we've got the magnitude of v. Now, can I simplify that? I think so. I think I can pull a 4 out of there and make that into, let's see, 2 root 13. I think 4 times 13 is 52. So we pull that 2 out. So there's the magnitude of our vector v is 2 root 13. So I'll just put that here. I know that's the magnitude of my vector there. Okay. What I want is a unit vector u. What's a unit vector again? We just said a unit vector is any vector that has a length of 1. So I could draw, for example, a unit vector here. That's a unit vector because that only has a length of 1, right? But it's not in the same direction as v. I want my unit vector to be in the same direction as this one. So that's no good. Okay, I want my unit vector to be in this same direction and to have a length of 1. Okay, so I'll call that u. And I'll even put a 1 there to denote that that's that length of the vector that I want. Okay, now, if you remember your geometry, this will be pretty easy. I'm going to draw this right triangle showing the x and the y components of my vector u. And I'm going to draw the same right triangle for my vector v, showing the x and y components. Okay, I know that this height is 6, and I know that this distance here is -4. Right? So that's my x and my y component of my vector v. But I want my x and y component of my vector u. So I want to know what's this length right here and what's that length right there. That gives me a magnitude of 1 in this same direction. Okay? Now, hopefully you've realized this by now and you recognize this diagram because you had to do problems like this in geometry. Okay? These triangles are, can you think of what the word is? Similar. Okay, they're not the exact same triangle because they're different sizes, but they are proportional to each other. Okay, what's their scale factor? What do I have to multiply this big triangle by to get this small triangle? What do I have to multiply 2 root 13 by to get 1? That's the scale factor that we're looking for. Okay, I could multiply 1 times 2 root 13, and that would give me 2 root 13. So if I knew my x coordinate of u, I could multiply it by 2 root 13, and that would give me the x coordinate of v. And the same thing with the y's, right? If I knew the y coordinate of u, I could just multiply that by 2 root 13, and that would give me the y coordinate of v, or the height of this triangle here. Okay. So what do I multiply 2 root 13 by to get 1? Okay. Well, if I take 2 root 13 and I times it by, what's that? That's its reciprocal. If I take that and I times it by its reciprocal, boom, we just get 1, which is that hypotenuse that I want, right? That magnitude that I want. So if that's what I do to the hypotenuse to get my unit vector magnitude, that's what I'm going to do to my height and my base, my y and my x coordinates, in order to get the x and y coordinates of my unit vector. Okay, so what's the x coordinate of v? -4. I'm going to multiply that times 1 over 2 root 13, and that will give me the x coordinate for my little unit vector u. So what does that give me? -4 over 2 root 13, and then the 4 and the 2 those simplify, so we get negative 2 over root 13. And hopefully you guys know by now that we need to simplify that to, we multiply the top and bottom by root 13 and we get negative 2 root 13 over 13. Okay, I'm going to do the same thing with the y-coordinate to get the y-coordinate of my unit vector. I'm going to take the y-coordinate, which is 6, right, times that by 1 over 2 root 13. And we get 6 over 2 root 13. 6 and 2 divide, and I get 3 over root 13, which simplifies to 3 root 13 over 13. So there's the x-coordinate of my unit vector, there's the y-coordinate of my unit vector. So I put those together, and here's my unit vector. It's got this x-coordinate and this y-coordinate. Okay, and there's my answer. Okay, so I know that negative 2 root 13 over 13, that's some decimal number. That is how long this is. That's the x-coordinate of my unit vector, and this is the positive y-coordinate of my unit vector. Okay, let's get this in a formula. Okay, so how did I find u? So let's say to find unit vector u so that u is in the same direction as some given vector v. Okay, let's write down this formula. Well, what did I do? I took v, and we figured out the magnitude of v, right, which was 2 root 13. This thing is getting blurry. Let's refocus it. Sorry, guys. I'll try again. That's better. Okay, what we did is we first found the magnitude of vector v, and then we took its reciprocal to get the scale factor that we needed to scale everything down to 1 unit. And then I just multiplied each component of my vector v by that scale factor to get the components of my vector u. That's what we did. Okay, so here's how you'll see it written. If I want to find u, all I need to do is figure out the magnitude of v, take its reciprocal, and then times that by vector v. And how do I do that? Well, I just did that up here. I took my magnitude of vector v was 2 root 13. I took its reciprocal and multiplied that by the x and the y coordinates of vector v. And then that's how I got my x and y coordinates of vector u. Okay. So I hope that helps, and we'll move on to the next video.